Hey there, class. Good afternoon. You can't get away from me even when I'm not there. So today we're going to do a quiz on section 4.4. But first I did want to finish the problems that were on that guided exercise that we did on Monday. This is the very last problem. So if you don't have that guided exercise out, be sure to get that out at this time. This was number 6, and this was the one for the teacher to do. And what we've got is we've got a function here that gives us the grams of radioactive plutonium as a function of time. So that's what the amount means right there. And so that is a function of time. And we're asked two questions. What is the initial amount of the material? So basically what that's saying is, what is A of 0? And so we plug in 0 for t. So 30 times 0.5 to the 0 over 70. Well, that's 30 times 0.5 to the 0 power, and that is 30 times 1. And so the answer is 30 grams. And that's pretty obvious. You just see here, you know this is going to go to 1 when t is 0. So that's the initial amount. Now, how much remains after 3 days? Well, that's just simply saying find A of 3. So we're taking 30 times 0.5 raised to the 3 over 70 power. Now I'm going to pull up my calculator, see if I can get this thing to work here. So I'm going to take 0.5 and I'm going to raise it to a power with parentheses 3 divided by 70. Close the parentheses. Let's try that again. Alright, so 0.5 raised to the power, and do this on your calculator while I'm doing 3 divided by, let me clear that again, 0.5 raised to, left parentheses, 3 divided by 70, close off the parentheses, and it equals, I get 0.9707. So 0.9707 is the 0.5 to the 3 over 70, so I multiply that by 30, and I've got 29.12 grams. These are in units of grams. Okay, now it says, what is the rate after 3 days? These are two different questions. How much remains after 3 days? That's the A function, because A is how much remains after t days. But there's a whole nother matter to ask, what is the rate of change after 3 days? In that case, we have to find the derivative, the first derivative, because that's going to be grams per day, grams per time or day. So I have to take the derivative of this. And this is the formula that we're going to use to find the derivative, where I've got a value a raised to the u power. So what I'm going to do, if I'm going to take the derivative of this, I'm going to take 30 out because that's a constant, and I'm going to take d dt of the 0.5 raised to the t over 70 using this formula right here. Okay, so I've got my constant 30. I am going to take a to the u, so I'm going to leave 0.5 raised to the t over 70. That remains part of the derivative. I'm now going to multiply that by the natural log of the base of the exponent, so that's the natural log of 0.5. And then I'm going to multiply that by the derivative right here That's going to be the derivative of the exponent. So the derivative of t over 70 is 1 over 70. And close that off. So that's what we have then for our derivative function. 30 over 70, which we can just write that as 3/7. So I have 3/7 times the natural log of 0.5 multiplied by 0.5 raised to the t over 70. Now I want to find out what the rate is after 3 days, so I'm going to find a prime of 3. So I have 3/7 times the natural log of 0.5 times 0.5 raised to the 3 over 70. Now we've already evaluated this, but without the 30. We know what this is going to be, but we'll go ahead and do it all together again. All right, so I'm going to take 3 divided by 7. I'm going to multiply that by the natural log of 0.5. And let's see here. So I've got 3 divided by 7 multiplied by 0.5 natural log. I multiply that by 0.5, and that's going to be raised to the 3 divided by 70, close parentheses, equals. It looks like my answer is, if I did this right on my calculator, is a negative 0.288. Negative 0.288 grams per day would be the rate of decay after 3 days. And we'll leave it there. These other 2 problems here, just for expediency's sake, to get you started on your quiz, we're not going to work those. They're really pretty much the same kind of problem, just a slightly different formula for each one. Now, I did want to work one other problem. Let's see. One other note about the quiz. I'm going to have our substitute teacher hand out a slip of paper that's got the 4 formulas that we used from section 4.4. Now, on no test are you going to be given these formulas, but this being our first quiz pretty much on 4.4, I wanted you to have the formulas because I'm more interested not in that you've memorized these yet, but that you're able to apply them. Okay, so on this first quiz, you'll have access to those formulas. The problem that I wanted to work on was one that requires logarithmic differentiation. Logarithm differentiation. We did a problem like this on the group exercise worksheet. In fact, I think I have that here, and we can maybe go look at it. Yes, this one here. Let me zoom in just a bit. And that one was, it's here somewhere, this one right here. So what we did is we started this problem. I'm going to rewrite it down here. We had y equals sine of x raised to the x power. Now I know that I'm going to use differentiation with logarithms here because my exponent involves the variable and the base is not e. Okay, so I need to get this exponent, this variable exponent, out of the exponent. So the trick here is we're going to take the natural log of both sides, like this. And the reason that we do that is because I can use the power rule of logs, which says that if I have the log of something raised to a power, I can bring that power out to the front. And so this formula then, or the equation then, becomes the natural log of y equals x times the natural log of sine x to the x. Okay, and then you take it from there. You differentiate. Now we're using implicit differentiation. When I take the derivative of both sides, the derivative of natural log of y is 1 over y times y prime, or dy dx. Over on the other side, I have to use the product rule. Okay, so because I've got two different things here that I'm taking the derivative of that are multiplied together, and so I would use the product rule at this point. So I guess I'll go ahead and finish this one out. Over here, the natural log of something is 1 over the something times the derivative of the whole thing, and the derivative of the inner derivative of y is y prime, or I'll say dy dx. Okay. Over here, using the product rule, I'm going to take this times the natural log of sine x. Now that's gone, right, because we brought that out to the front. So I'm just basically taking the log of sine x. And the derivative of the natural log of sine x is going to be 1 over sine x times the derivative of the inner, right? Because the derivative of the natural log of something is 1 over the something times the derivative of the something that's inside, and that's derivative of sine x is cosine x. And then plus, I take the derivative of x, which is 1, times the natural log of sine x. Now, I want to solve this for dy dx, so what I'm going to do is I'm going to leave the dy dx here. I'm going to multiply both sides by y, so what I get here is y times, and I'm going to simplify this right-hand side. Now I've got cosine x over sine x, which is cotangent x, so it's x times cotangent x plus the natural log of sine x. And now I substitute what y is. I'm going to put that in for y, so what I've got there for y is sine x to the x. So last step here, dy dx, substituting in sine x raised to the x power, that's what the y is, and then that's going to be multiplied by x cotangent x plus the natural log, and now it's going off the page here, the natural log of sine of x. Okay, so that's what we call differentiating with logarithms, or what we call logarithmic differentiation. One other example that I wanted to work on that, and then I'm going to let you guys work on your quiz. Let's suppose that here's my function. So new problem here. I've got y is equal to x raised to the 10x. And I need to find y prime. Well, what I recognize is I've got my variable x up in the exponent over here, and this is not an e, it's not an exponential, so I'm going to have to take the natural log on both sides. So I'm going to take the natural log of x raised to the 10x power. Using the power rule of logs, my equation is going to become the natural log of y equals 10x times the natural log of x. We're using implicit differentiation here, so what I am going to do here is I'm going to take the derivative of both sides. Now the derivative of natural log of y, derivative of natural log of something is 1 over the something times the derivative of the something. So the derivative of y in implicit differentiation is just dy dx. Over here I am going to use the product rule on the right hand side because I'm taking the derivative of two products. The 10 is a constant, so I'm going to leave that out here. So the derivative of x natural log of x, I'm going to take x times the derivative of natural log of x, which is 1 over x. Plus, then I'm going to take the derivative of x, which is 1, times the natural log of x. And so I get that. And I close off the parentheses there. So what I end up with is, coming down here a little further, I think what I'll do is slide this over this way. So what I end up with is I've got 1 over y dy dx is equal to 10, and that's going to be multiplied by this x times 1 over x is 1, and then that's going to be plus just the natural log of x, like so. I have to solve for dy dx, so I multiply both sides by y. So I have dy dx is equal to y times 10 times 1 plus the natural log of x. But what is y? Y was just simply the original function, which was coming back up here where we started, x to the 10x. So I'm going to do the substitution over here by putting that back in, x to the 10x. So for y, so I have dy dx is going to be x to the 10x multiplied by 10 times 1 plus the natural log of x, like so. And just simplifying this a bit, I can pull the 10 out because these two things are multiplied, so it's going to be 10x to the 10x multiplied by 1 plus the natural log of x. Okay, and then that would be my final answer for that problem. That is it. That's dy dx. Okay, so just to recap there, I'm taking the natural log of both sides so that I can bring my exponent out to the front. So that's what we did up here. So this 10x came out to the front. Then I took the derivative of both sides, multiplied both sides by y to get dy dx by itself, and then just did some simplification. Okay, so you'll see a problem like that on the test that's going to require you to do that. One other note I wanted to mention to you is some of the rules of logarithms. Now, suppose that I've got the natural log of a times b over c. I can split this out. Hopefully you remember this from your algebra class or probably your algebra 2 class. That's the natural log of a plus the natural log of b minus the natural log of c. So what might appear to be a really complicated expression, that's where I've got two things multiplied like a rational expression, is what I'm saying. If this was a complicated rational expression, boy, I can make things pretty easy on myself, or at least much easier if I split this out into 3 different terms. Okay, so that's the rule of logs. That's the product rule and the quotient rule of logs all in one shot right there. All right, let me see if there's anything else. I don't think that we have anything else to cover. Keep in mind that Friday the 4.4 Math Excel is due. And that is it. I will see you on Friday, and good luck on the quiz. Okay? I'll see you. Bye.